Hey folks, how's it going? This is Mr. Moray coming to you with a video on the law of sines, the case of side-side angle. All right, this lesson, we started this lesson in on the, I believe it was the 13th of March, the last day before we kind of had to close down for a little bit. We started it. We talked about like a kind of introduction to the ambiguous case here, but we didn't actually fully get into it. And so what I said on that day is I said, hey, I am going to have a video up for you to finish out those notes. And so that's what we're going to do. We're going to look at the ambiguous case. In this video, I'm going to do a couple of examples, right? There'll be at least one or two for you to try. And then after this, if you're still stuck on this, I need you to reach out to me so that we can figure out how to help you with this, okay? So what you're seeing, this page, you're going to find this in the 312 handout. Again, this is 2019-2020. So 3-12, okay? You're going to find this on page 4, okay? And not like the fourth sheet, like the fourth page. So what that means is it means, I believe, the back, there should be 3 sheets of paper. If you have the actual hard copy, the back of the second side. So make sure before you start this video or you go any further in this video, you find this, what you see on the screen right here. Okay, so I'll just clear out this calc so I can use it if needed. But here's the deal, and I think I allude to this in the do now video for this lesson. So look, we got 3 kinds of given informations essentially that we can be provided with. We have a situation where we're given 2 angles and a side. We have 2 angles and an included side. And now we have 2 sides and an angle. Now the problem with 2 sides and an angle is that depending on the information that you're given, there, as you can see, could be 1 possible triangle, 2 possible triangles, or no possible triangles, right? So we have no triangle in this case, we have 1 possible triangle, and we have a case where there's 2 possible triangles. What this means for you is that if I ask you to solve an equation, okay, or rather to solve a triangle, right, there could be more than 1 answer, or there could be no answers at all, or there could be 1 possible answer, okay? And so what I alluded to in class is, let's say I know this. I have these 2 sides, right? And I know that the height of my triangle is, I don't know, some measurement h. I'm also given b, some measurement b, which represents a side. So I'm given a side and I'm given an angle, call it theta. And I'm given another side. So because we're looking at this case, side angle. And I don't know what's going on with this side. It's just kind of hanging out there in no person's land. Here's my note, none. So look, here's what we talked about in class. And you can see this in the diagram. If A is not at least as large as H is, right, it's never going to be able to hit, right? Because the idea is we have this third side. Now look, we don't know the length of this third side. Okay, this is unknown to us. But the idea is that if A is not at least as long as H, well, look, these are never going to connect. So this triangle is not a valid triangle. Okay, that is true. So that's this case right here, no triangle. Okay, on the other hand, if A is actually equal to H, then A will come straight down and you'll form a right triangle. That's the only way that can happen, right? Because if this is H, right? Well, this is forming a hidden 90-degree triangle. And so what we know is that since this is perpendicular, if A was equal to H, it couldn't be this side of the triangle, right? Because if it was, it would be across from the 90-degree angle, making it the hypotenuse. But the hypotenuse has to be the largest side, and if A is equal to H, then that can't be it because A is supposed to be more than H. So this is the case where A is actually, in that case, couldn't be the hypotenuse. It actually has to be the height. So if A is equal to H, you have a special situation right here where you have a right triangle. Now, what happens when A is more than H? So look, when A is more than H, let me just see if I can back this out. Okay, now when A is more than H, what we know is that it's going to hit, okay? It's going to hit the triangle at some point. How many points it hits at depends on B. So you can see we've got two situations. One where A is more than H and less than B, and one where A is at least the same length as B. So if A is actually less than B, then you run into two situations, okay? You run into a situation where it could come down like this, and then you run into a situation where it can come down like the dotted line. So you get two triangles. You get this red triangle that I'm drawing now, and then you get the green triangle that I'm drawing now, right? This bigger triangle here. So that's actually two different possible triangles, and if I ask you to solve, you actually have to solve for both. Again, this is assuming that A is less than 90 degrees. It's an acute angle, okay? On the other hand, if A was actually more than B, right, what we know is that there's really only one option. It's going to have to touch C, and it can only touch C in at most one place. And if you think about it, if A was actually more than B, there wouldn't really be a way for it to snap back like this. So the reason that this is happening is because A is more than H, so it's hitting the last line, right? But it's less than B, so in that case, it could either, right, we could have it snap back or snap forward, and that would actually give us two different options. But when A is more than B, right, there's no way for A to snap back over here. You don't form, it's not going to form like a legitimate triangle there, okay? So that's going to only give us one triangle. So that's when A is acute. When A is right or obtuse, it's actually better in a sense because the two triangles situation doesn't exist. So either A is right, it's 90, and in that case, A has to be at least the same as B, because if you think about it, if A is right, then the side opposite A is the hypotenuse, right? And if little a is the hypotenuse, it has to be the longest side. If it's less than or equal to B, it's not the longest side. So that can't happen. Okay, so it's got to be more than B. Now, in this case, if I have a obtuse angle, more than 90 degrees, then as long as A is more than B, I'm going to end up with one triangle. Okay, so there are a few different cases. We have to think through these ones logically. The other thing I'm going to point out is that, again, it says we're given AB and the measurement of angle A. But remember, the big thing we have to know about this is that how you label the sides does not necessarily matter. If I'm given any two sides in any one angle, then I can call that angle A. Assuming I've got the side across from it, I call that little a, and then I've got another side adjacent to big A that I call big B, as you see in these examples in the ambiguous case table, those 6 examples. Now, what do we do with this? So here's my example. So each triangular wing of a model airplane has one side that joins the wing to the airplane. The other sides have lengths of 18 and 15 inches. The side with the length B meets this airplane at angle A with a measure of 30 degrees and meets the side with length A at point C. Okay, we don't know that yet, but we'll be able to figure this out. So I need to find each measure. So the first thing I'm going to do here is I'm going to look at A and B, and I'm going to come back and look at this. So what I know is that A is less than B. That is true. A is less than B. That's a given, right? B is 18, A is 15, A is less than B. It's just the fact is 15 is less than 18. Hopefully we can all agree with that. So what does that mean? So that means I could have two triangles, right? Because that's what usually happens, but I have to see if A is more than the height. If it's more than the height, then we're good. So if we look at this situation, let's drop our height down here. Okay, we'll drop our height. That makes a 90-degree angle. And to figure out the height, well, if I want to figure out the height, well, what do I know? Well, in this case, what I know is the height. Let's see if we can just move it without rotating. I know that the height is opposite the 30-degree angle, and 18 is the hypotenuse. So I know that the sine of 30 equals h over 18. Sine equals opposite over hypotenuse. So 18 sine 30 is equal to h. Now, you might know that sine of 30 is 90 is not 90. Sine of 30 is equal to 1/2. It's one of those special ones. If you don't know that, you could plug it in and you could get that h is equal to 9. Now, this is important. Okay? So A is more than h, right? But A is less than B, meaning this is an ambiguous case. There's two possible triangles. So let's see what they look like. Okay, here's one possible triangle. Okay. So in the first case of the triangle, A snaps forward. Okay. Little a rather. And I get a 30-degree angle. I get an 18. I get a 15. It looks like that. The other scenario is that A actually snaps the other way. So here's my two sides. I wish I could be a little bit more precise sometimes with my pen. So here's my wing, and then instead of going down, it actually snaps back this way, okay? Rather than snapping this way. Okay, and I'm going to make that a little bit bigger now that I've done that for you to see. So again, we have a triangle that looks like this. This is our original triangle. Ugh. Okay. Okay, here we go. So our original triangle. There we go. And then it comes down and it snaps back like this. So here's my 18, my 15, my 30 degrees. So essentially, I'm going to have two answers for B and one answer giving me, I'm going to have two possible answers for B because I know that this is A. This is A. This is C. This is B. This is B. This is C. This is A. Okay? So what that means is that I'm going to have two possible answers for B, which will in turn give me two possible answers for C, which will in turn give me two possible answers for little c, right? Because little c depends on the sign of big C. But if C has two possible measurements, then it has two possible signs. So little c has two possible values. So to find B, I'm going to use the law of sines. Okay, so what I know, let's take a look at it. I know that the sine of A, and the sine of A, well, that's the sine of 30. If I take the sine of 30 over the measurement of the side, corresponding side, which is 15, it's got to be equal to the sine of B, which I don't know, over the corresponding angle side measurement, which is 18. So to get B alone, I'm going to multiply by 18. So I got 18 sine of 30 over 15 equals sine of B. And then to get the answer for B, I'm going to do the inverse sine of 18 sine of 30 over 15. Okay, so you'd either type inverse sine of and then type this into Wolfram, or you would type it into your calculator. So 18, so clear that out. So second sine for sine inverse, 18 times the sine of 30 over 15. Close. Okay, so when I do this, I get B is equal to, it's approximately equal to 36.870 degrees. Okay? That's what the sine inverse tells me. So, cool. So what I need to do with that is that could be one possible answer for B. So we can imagine that B was this, okay? So basically what we have here is, if you think about this triangle, let's come back up here. This is an isosceles triangle, right? Because this A is equal to this A. So then this angle is equal to that angle. Okay, so in other words, if this is 36 point whatever, this is 36 point whatever. So if these are a flat line, how do I find my other angle? Well, a flat line, the two angles have to add up to 180, right? So if I do 180 minus 36.870, I get B, or B is approximately 143.13 degrees, okay? So if B is the 36 point something, I get this, 36.870, and if it's the 143.13, I get this. And so what this is going to mean is, this is going to mean for us two possible scenarios, okay? And I'm going to show us our two scenarios and how they exactly play out. And we'll do this on the right side of our paper. So hopefully by this point you guys have this down, part A in the notes. Part B, I need to determine big C and little c. So I'm going to look at two possible scenarios. In the first scenario, we have when B is equal to 36.870. In the second scenario, we're going to look at when B is equal to 143.13. Okay, because both of these will give us the exact same answer. They'll solve this problem right here. So they're possible answers. Okay, so now I'm going to start with this. So if this is B, well, I can figure out C, because I know that 36.870 plus 30 equals 66.870. So therefore, the measurement of angle C is equal to 180, which is what a triangle adds up to, minus 66.870. So 180 minus 66.870. That gives me 113.13. So that's this triangle. MC equals 113.13. Okay, so solution one, angle-wise, is that we get 36.87, 113.13, and 30 degrees. Those are the three sides. And now I need to get the final angle. Okay, and this is a time where we're going to have to use our guesstimate because we have to have sine C when we actually solve the last part. So now I know that sine of 113.13 over little c equals, well, I'm not going to do sine of B because we guesstimated B. So I'm going to do sine of 30 over 15. Okay. So what I'm going to get in my final answer is that when I multiply, I'll do C sine of 30 equals 15 sine of 113.13. So C equals 15 times sine of 113.13 over sine of 30. So let's see what that looks like. So I have 15 times the sine of, in this case I'll call it my answer. You could just type in 113.13 over sine of 30, which we know is a half. So essentially it's just doubling. And what I get is C equals about 27.588 units. Okay? And if we think about it, if we look at what we got here, C would be the biggest angle, and it's across from the longest side. Does that make sense? Okay, now I'm going to do my last one, which is, what if it was 114.13? 143. So if it was 143.13, then the total angles would be 143.13 plus 20. So that'd be 163.13. Okay. Now, if that was true, what I'd have happen is that I would have the remaining angle. I'd have to do 180 minus 163.13. And I'd get 16.87. Right, to represent that little sliver there. Okay. So on the other hand, this is actually going to give me the smallest side. Okay. Now to find out C, I'm going to do the same thing, except I already know the formula. So it's going to be, since I'm going to just manipulate this. So C has to equal 15, because I would just be setting up this ratio again. 15 times the sine of 16.87 all over the sine of 30. Okay, so 15 times sine of 16.87 over sine of 30. Okay, and what I get is 706 units. Okay, so there's two possibilities here. There's two possibilities. Either big A equals 30, big B equals 36.87, C equals 113.13, little a is 15, little b is 18, little c is about 27.588, or second triangle, a equals 30, b equals 143.13, c equals 16.87, little a is 15, little b is 18, and little c is about 8.706. Okay, those are our two possibilities. Now remember, the two possibilities exist because we have a triangle in which we have an A value that is smaller than B, yet more than the height, creating an ambiguous case of two possible triangles. We solve for B. We do its supplement, giving us the other possible value of B. So this would be our step where we're figuring out the possibilities, finding our two values for B. Okay, based on that. So this, by the way, the top one comes from the law of sines. The bottom one comes from supplementary angles. Assume it was the first, finish solving. Assume it was the second, finish solving. Because by changing the angle of B, you change the angle of C. By changing the angle of C, you change the length of the side across from it, little c. So we go from being the largest angle and the longest side to the smallest angle and the shortest side. Okay, this is going, try to fit this in 312 right where you see this. Please make sure you rewind and make sure you understand everything. Again, this little c, I just repeated the work from this problem, but I just kind of, instead of doing it all out, I just switched the sign of 113 to the sign of 16.87 because it's the only thing that changes. All right, so again, please make sure you understood what I did here. Pause if needed. And then in a moment, I'm going to move on to the thing on the top of the next page. All right, so this was given as an example for you guys to try. So here, I'm in a different situation, and let's see what we got. So here I want to know how many triangles are possible, why, what are the unknown measurements, round to the nearest tenth. This one we'll do together. Maybe it's like a we do. Okay, so what I want you to do is think about this. I've got an A of 21. I've got a B of 18. So already the side that is opposite of A, we don't know how it lies yet, but for now we know that it is 21 and it's more than B. So if we go back to this situation, what happens when A, and now we also know if we were to calculate the height, let's try this, the height is equal to 18 times the sine of 25. Okay, and that's because sine of 25 equals height over 18. So we'll try that. 18 sine 25. So we have a height of about 7.6. So we now definitely know that A is more than the height. It's acute, so it's going to follow one of these four. It's more than or equal to B, so that leaves us in a situation of one possible triangle. One triangle. A is more than H. A is more than or equal to B because it's more than B. Okay, noticing that A is 21, making it bigger than 7.6 and 18. So this is nice because we're only going to get one triangle in this case. Okay, it's going to look like this. Okay, we have A, we have C, we have B, we have 18, we have 21. Okay, that's what we know. And I forgot to mention 25 degrees. Okay, so what I want you to do is this. Take a second, now that we know there's only one triangle, pause the video, try to solve this triangle out, and then in a moment, unpause, and I'll show you how you could solve. All right, so basically here we need to solve two sides. We have an angle A, an angle B, an angle C, a side little a, a side little b, a side little c. This is how I always set it up. So we know this is 21, this is 25 degrees. We know this is 18. It's too bad we don't know that there's a rule about what the sides have to add up to, or this would be a lot easier. So here's what I'm going to do. Let's set it up. So I've got sine. What's the only I need to have two things that I know. Because if you're going to solve an equation, right? If you're going to solve an equation and you want one variable you want to solve for one variable, you can only have one variable in the equation. So for example, at this point, I can't do sine C over C equals sine B over little b, because I know that'd be three pieces of unknown information. But notice how this one's different. So here in this case, okay, notice how I have only one letter that I don't know. And even though I did put a little b in here, I actually know what little b is. I actually happen to know that little b is 18. So see, now you can solve for sine big B because there's only one thing in this whole equation you don't know, and it's the big B. So if I do this out, you're going to get b. I multiply and I take the sine inverse. So I get the sine inverse of 18 times sine 25 degrees over 21. Okay? And let's see what happens. Sine inverse 18 sine 25 over 21. And if you think about it, 18 sine 25, that's the opposite. Right? Okay. Now, right, opposite, hypotenuse. Okay, let's see what we get. 21.23. Now, I wonder what happens if we try to do the complement. 180 minus answer. Let's see if I take that answer, and I now take the sine of this answer. I'm interested to know what happens. No, actually, I want to do the sine. So what I want to know is if I do the sine. Now, what if I do the sine of 21.23? So notice how, now that was an estimation, right? But if I actually do this sine, you're going to see that the numbers are exactly the same. So that's what I'm getting into. There could be more than one way to do this. But in this case, because of how everything is oriented, I know that I'm only going to be focusing on this is going to be 21.23. They actually want us to round to the nearest tenth. So let's do 23. Actually, 2 degrees. Okay, so you only do the 180 minus. That was just for my personal interest. You only do that when you have a situation where there's multiple triangles. But again, because A is more than B and A is more than H, that will not happen here. Finally, C, we can get C because we have 180 minus 25 minus 21.2. Again, it's going to be approximate because 21.2 is not what we really had there. 133.8. So let's call this one. Actually, that's pretty fair if you think about it, because if these then add up to 180. Okay, so 25 plus that, 180. Okay. Lastly, we need to find side C. So I'm not, in this case, I have to use this sign. I don't like the idea of using the sign of, because I know it's not an exact answer, but that's the part that has the unknown variable in it. So I have to. Now, in this case, do I use sign A or sign B? I'm going to use sign A. And the reason is, remember, because we know that A is exactly 25 degrees. If I use sign B, you can see now how I would be using a sign of an estimate and a sign of another estimate. So you're already doing the sign of two numbers that are not exact, and then you want to find exactly a side. There's just too much unknown. So my strategy is, if you want an exact answer, reduce the amount of unknown and guess as much as possible. Okay, so now what we're going to get is, when we combine, we're going to get C sine of 25 degrees is equal to 21 sine of 133.8 degrees. And then C is therefore equal to 21 times the sine of 133.8 over the sine of 25. So what is that? 21 times the sine of 133.8 out of the sine of 25, and that is about 35.9 units. Again, notice it is very much bigger than the other two. Notice it has a very much bigger side length. It's going to be longer. If it's got a longer side length, it's across from a longer angle. We generally tend to find that in there. So that's more or less how we're going to do it. Again, you're just setting up the information you know. Again, getting that one piece of unknown so I can then finish solving out the rest of the triangle. Okay, this has, again, one possible triangle because you know that A is more than B. Okay, so that will be something that is very helpful to know. Okay. Okay, so please make sure you understood what I did here, and then in a moment I will move on to the next part. All right, so moving on down, I've got this information right here. So I'm going to do one more of these. I encourage you to actually do this if you know how to do it already, okay? But then I'm going to kind of put this back and we'll see what we can do in terms of one for you to do. So there's actually two on this page, one with an A and a B, okay? And one with an A and a C. So the first thing I always recommend you do in this case is I recommend you actually try to make the triangle. So here I go. Okay, so here's my triangle. Here's an A value of 70. Let's I call this A, C, and B. And actually, what I'm going to do is I'm going to reorder how I'm going to call this, because I actually kind of want to have it set up like before, and it doesn't really make a big difference as long as you're consistent. So what I know is that C is 26. A is 25. And what exactly is the height? So let's see if we can figure out the height. So we know that sine of 70 equals the height over 26. So 26 times sine 70 is the height. So we have the height is approximately 24.43. So what this tells me is that A is more than the height, but it's less than the other side that I have. So how many triangles is this going to give me? This is a scenario of two possible triangles. So in one of them, it comes back like this, right? The A snaps back. And on the other hand, the A snaps down. Okay, so those are the two. One where and that's not like the most accurate. So let me just show you. It comes up like this again, the same angle, but then it comes down this way instead of snapping back this way. So you have two possible triangles. So here's what I want you to do, folks. I want you to take a second and I want you to try to solve both triangles, okay? Because there's two possible answers here. I want you to find the B value, because you need to find that, okay? Or in this case, I would say the C value, because we don't know what measure angle C is. Though I guess it doesn't really matter what you do. So I need you essentially to find for me the two possible triangles. How about we start like this? Because we know little c, little a, and big A. So here's what I want you to do. Step one, you need to start with finding the measurement of big B. Then I want you to find the measurement of big C. And then I want you to find the measurement of that. So actually, because of the unknown information, I want you to start with finding the measurement of big C, and then based on that, I want you to find me the possible big B's and little b's. Okay, so take a second, do 1 and 2, and then when you're ready and you think you got the right answer, unpause, and I'll show you how to solve. All right, so here we go. So, case 1, big C. So let's set it up. So sine of big C over, what do we know about C? It's 26, equals the sine of 70 over 25. Okay, because A is 25. So what that means is that C is equal to the sine inverse of 26 times the sine of 70 over 25. Okay, our calculator is the only thing that can do this, so you're going to need to use Wolfram if you don't have one. 70, close out, divide by 25, close out. So what I get is 77.76 degrees. Okay, and then that's C1, so I'll call this C1. C2 is 180 minus 77.76. And again, if you don't know why I did the 180, go back to my last example where I show you the isosceles triangle, 102.24 degrees. Okay, so those are my two possible angles. So either C is 102.24 or C is 77.76. Okay, so this leads me to my two possibilities. First of all, A is 70, B and C is 77.76, or A is 70 and C is 102.24. Okay, in that case, if we take 70 and add 77.76, we get to 147.76. And if we subtract that value from the answer, 180, now I'm going to have to actually do minus 147.76. I get 32.24. And again, the 32.24 has to be because these all have to add up to 180. And if I add these up, I can see I get 172.24. Right? So 180, again, I need to get B. So I add these up, I get 172.24. I take that away from 180, and B needs to be 7.76. So those are the B1. So these will allow the three angles to add up to 180 degrees. The last step I need to do here is I need to make sure that I get this all set up. So I'm going to do sine of 32.24 over b equals sine of 70 over 20. What do we do for that? 25. And here I'm going to use sine of 7.76 over b is sine of 70 over 25. Okay? So now to solve for b, what I'd end up getting is b sine of 70 equals 25 sine of 32.24. So b equals 25 sine of 32.24 over sine of 70. And here I'm going to get b sine, so you can see how it starts off the same, right? B sine 70 equals 25 times sine of 7.76. So the solution method is exactly the same. B equals, so see what's going to change? The only thing that's going to change, I'll show you in a second, is the sign. See, the only difference here, this was 32.24, this was 7.76, okay? So I'm going to do 25 times the sine of 32.24 over the sine of 70. Please make sure you close out your signs because it will give you the wrong answer. So here, B is about 14.19 units. And now if I go up, and I'm just going to click go up, I'm going to take my 32.24. Hopefully I didn't overclick there. And change it to 7.76. Pull that back. And now try this. And I get B is equal to about 3.59. Okay? So in this case, what I get is I get little a is equal to 25, little c is equal to 26, little b is about 3.59, and in this case I get little a is 25, little c is 26, and little b is about 3.59. Okay? So please make sure you understand how I got solution possibility 1 and solution possibility 2. And keep in mind that if I ask you to solve a triangle and there are 2 possible cases, you have to give me both possible cases. Okay, so again, please make sure you understood this completely, and then in a moment I'll move on to the last problem. All right, I'm excited to do our last problem. Again, these are all coming out of the packet, so please make sure you are looking in the right place, okay? Okay, so on to the last problem here. What I have is I now have B is 45, A is 28, little b is 27. So I'm going to need to ask you to go ahead again on your own, completely this time. Make me my triangle. Set up my triangle, solve all possible triangles that exist. If there's 1, solve the 1. If there's 2, give me both of them. If there's none, say there's none and show why. Okay, we'll pause the video, try to do that, and then when you're ready, unpause, and I'll show you how to solve. All right, so hopefully you consulted the table a couple pages back. I'm going to start with the knowns. So I've got my angle of 45 degrees. I've got, that's my B. Got to be careful here. So this is where you got to be careful. All right, I've got my A and I've got my C. I believe this is good. So A will be 28, the thing that I know. Then I'll have my side B, which I don't know, but I know it's 27, and then I'll have C. So if I do an analysis again of the height, so far if we go back to our table, we know that in this case, the thing that I do not know, the thing that I'm working with here, 27, let's say that's our A. If we go back to this situation, the A and the B are kind of reversed. So this is our B, and this is our A. So the thing that I'm trying to see if it can connect, right now it's less than the height. So basically I'm either going to have, or less than the side I do know rather. So either it's going to be less than the height and I'll have no triangle. So again, I just want to clarify here. In our situation, this is really B. This is what our situation looks like, okay? So if our B that we are given is actually less than the height that we're about to calculate, we're going to have no triangle. But if it's greater than the height and less than the other known side, we're going to have two possible triangles. So let's see what happens. So we know that the height is equal to the sine, 28 times the sine of 45. Now, I know you're thinking, Mr. Murray, this got to be 45, 45, 90. That's not necessarily true. And we've got a 19.799. Doesn't really matter. The point is, it's definitely less than A, or rather, in this case, B. So therefore, we're going to have a couple possible situations here. Okay, let me see if I can copy and paste. Let me see if I can copy and paste what I've got right here. Okay. I thought maybe this would be a little bit easier. So here's my copy paste. So here we'll have two situations here. Either B will snap like this. So we'll have a 27, a 28. But because of the relative sides, B could actually snap back like this. So we could have it look like this. And remember, what you call the sides doesn't really matter. It's more that we have to analyze what we're given. So the fact that this A, B, and C is oriented differently really makes no difference at all. In the end, I could take these and reflect them about the middle, and you'd get the same A, B, and C, right? These are just shapes hanging out anywhere. Okay, so here again, I've got 45, I've got 27, and I've got 28. So these are my actual two possible triangles. Okay, so now I'm going to be stuck solving these. So let's start with B. Let's start with A. We need to find A. This is the next piece of information we find, right? Because I can find big A because I know the other three pieces of information. So what I know is I know the sine of big A over 28 is equal to the sine of 45, which is big B, over 27, which tells me that A is equal to the inverse sine of 28 sine 45 over 27. I think what makes this problem, one of the things that makes this problem difficult is the fact that I'm mixing up the letters on you. So you're used to seeing things stated in a particular way, and now I'm mixing them up, but the ideas remain the same. Okay, so A, 28 sine 45 over 27, A is approximately 47.16 degrees, meaning that's A1. Now A2, right, if I snap this back, then this was 47.16, which means this is isosceles, both sides being that length. So that would have to be 47.16. So this would have to be 180 minus 47.16 because they have to add, these would have to add up to a straight line. So we're going to call it minus. So I have 132.84. Okay, those are my situations. So either I have 47.16 or I have possibility B, 132.84. Okay, in the first case, it doesn't matter here. A is 25. And in this case, I have also, sorry, A is 45. Okay, so these are my A's and my B's. Actually, I mixed them up. See how it's so easy to do that? Okay, so if we're counting my mistakes, there's a mistake for me. Okay, so this is B, this is A, this is B, this is A. Okay? Now I need to find C. So in this case, I know that they add up to 45 plus 47.16. So they add up to 92.16. 45 plus okay, these add up to 177.84. Okay, so that means, again, the three triangle side angles have to add up to 180. So first I'll do 180 minus 92.16. Okay, so I've got 87.84. That's the first triangle, because, again, that makes these three add up to 180. Now, 177.84, I'll try to do this in my head. So 2 gets me to 179. 0.16 gets me to 180. So two possibilities: these three which add up to 180, or these three which add up to 180. Remember, we were given the B. We use the law of sines to solve for A, and then C was whatever we needed for the three angles to add up to 180. Now I know A and B. My goal is to get C. So to get C, I'll start on the left. And again, I've got to use guesstimates that I'd honestly rather not use, but c'est la vie. So sine of 87.84 over C is equal to, remember, we use the exact sine. I don't want to see the guesstimates being used. Sine of 45 over little b. Let's just double check that that is 27. Silly me, I should have seen that right here. Okay. So I'll do C. Again, I'll cross multiply. C sine 45 equals 27 sine 87.84. So I got C is 27 times sine of 87.84 over sine of 45. Okay. And I'm going to take that and I'm going to divide it by sine of 45. Actually, a special value. And that's going to be, C is going to be about 38 point, let's call it 16. Here, similar idea. I'm just going to skip a little bit through. So it's going to be the same setup. It's going to be similar at least. Sine, so see the difference? This is 2.16. So sine 45 over 27. So that's supposed to say 45. Okay? So now my final answer would be C times the sine of 45 is equal to 27 times the sine of 2.16. So to get my final answer, I need to do C equals 27 sine. So see the difference? It's the same except those angles over sine of 45. Okay? And it's so similar that I'm just going to come back up here, copy what I had before. Cool. It's a good calculator hack. I recommend you learn. It'll save you, for those of you who want to save time, boy, will this save you time. 2.16. Delete that last character because I don't need it. And I get 1.43. C is about 1.4, actually 1.44. Okay, you can see it's significantly shorter because the corresponding angle is significantly less. Okay, so these are so those lead to our two solutions. Those are, so we got big B is 45, big A is 47.16, big C is 87.84. Then I've got accordingly little b is 27, little a is 28, little c is about 38.16, or I have big B is 45, big A is 132.84, big C is 2.16, and then I've got little b is 27, little a is 28, and little c is about 1.44. Okay? So, and those are our two triangles. All right, folks. So hopefully this video made sense to you. I appreciate you sticking through. I know this video was pretty close to an hour in length. Big things to take home in this video. So remember, there's 3 different kinds of scenarios of unknown information. We started with angle, angle, side, and angle, side, angle. I gave you those setups because in those cases, you usually have one solution. It's a lot more straightforward. Your 2 angles lead to a 3rd angle. And then from there, all you do is you set up your law of sines with the known information, aka the given side. Boom, 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 done. And we've seen that. The side-side angle gets a little bit more complicated because the answer kind of depends. Is the angle you're given right, obtuse, or acute? Right? Is the side you're given shorter than the side that's opposite the angle, right? Because you're given 2 sides, one opposite the angle and one not. Is the opposite the angle side shorter or longer than the other one? Is it shorter or longer than the height of the triangle, as you can determine based on sine and cosine? Okay, in this case, usually sine. This is all very, very important information, and what it will do is it will impact your possible solutions. Okay, folks, so following from this video, what I want you to do is I want you to complete the assignment at the end of the 312 packet on the very, very back, at the very, very end, where you practice with the triangles, keeping in mind, given law of sines, that you could have more than one possible triangle. Okay, I want you to be aware of that. So you need to think about, what information am I given? Am I given AAS or ASA or SSA? Based on that, what's my situation? And then solve the triangles, okay? Please keep in mind, it's completely open note. Use 312, use the table, use the video to help you, okay? So folks, we can do this. I want us to finish law of sines strong for us to head into law of cosines, all right? So keep at it. Keep asking questions. If you need to do like a Google Hangout, feel free to reach out to me over Remind or email. And remember, you can do it. All right, folks, thanks for watching. I appreciate that you taking the time. Please make sure you like and subscribe to stay up to date with my newest videos. And please stay up to date with everything related to what we've been doing during the kind of closure at we.willnot.fail. Okay, thanks again for watching. Hope you enjoyed it. Have a wonderful day, and don't forget to love math.